Alright, welcome back guys, yet to another video. Must thank my viewers and subscribers. So this is a continuation from the first video on matrix theory part A. So this is matrix theory part B, and we were looking at matrix multiplication in the last part of the video clip, and we will continue. Alright, so right here we have two square matrix or two by two matrix, and we're going to multiply matrix A times B. Now you notice inside the elements we have letters. Alright, so what I'm going to do, I'm going to show you how to get this number here when we multiply two by two matrix. Now whenever we're multiplying matrix, we always multiply it row by column. So we're gonna use the first row of the first matrix with the first column of the second matrix. So we're gonna have A times E plus B times G. Alright, so we always put a plus there. And to get the second element in this matrix here, we're going to still use the first row of the first matrix, but the second column of the second matrix. So it's going to be A times F, so we're going to leave a little space. So it's going to be A multiplied by F plus, so A times F plus B multiplied by H. And to get this element down here, we're going to use the second row of the first matrix, the first column of the second matrix. So it's going to be C times E plus D times G. So it's the second row of the first matrix with the first column of the second matrix. Sounds confusing. Alright. Anyways, to get this number here now, we're going to use the second row with the second column of this matrix here. So it's going to be C times F plus, can you tell me what next to write? What you think should go here? Okay. D times H. Very good. And that's how we multiply two square matrix. Alright. Let us look at a question with numbers. So here we have two matrices named P and Q, and we're asked to multiply P times Q and Q times P. Alright, so we're going to work out the first part. PQ, so we're going to set it out like this. Alright, so remember that to multiply two matrix, we multiply it row by column. Alright, now whenever you're multiplying matrices, you see, try to get them in this order. For example, try to get this one first, then that one, then that one, then that one. Alright? Just try to have a little sequence in what you're doing so you don't get mixed up. Alright. So we're gonna get this number here, right? So it's this row by that column. So we're gonna set it out. All right. So it's gonna be 3 multiplied by this -1 plus -2 multiplied by 0. All right, and that's how we get this element To get this other element over on the right hand side, we use the same row but with the second column. So it's going to be 3 multiplied by 3 plus -2 multiplied by 1. To get this one now, we're not going to use the first row. We're going to use a second row with the first column. So it's going to be -1 times -1. All right, notice that I always start at the top here going down. All right, so it's going to be -1 multiplied by -1 and 4 times 0. And the last one, all right, can you set it out? Let me give you 5 seconds. All right, so it's going to be -1 times 3 plus 4 times 1. All right, and we simply just compute this thing here. So this will give us -3 plus 0, and -3 plus 0 is just -3. 4 times 0 is just 0. -1 times -1 is +1. 1 plus 0 is 1. 3 3s, 9. A positive and a negative give you a negative. 2 1s, 2. 2 from 9, 7. -1 times 3 is -3. 4 times 1 is 4. -3 plus 4 is actually 1. So this, ladies and gentlemen, is PQ. All right. Now our next task is to work out QP. All right. What they want is just to flip it around, but you say, boy, sir, you're supposed to get the same thing. Because remember, with numbers, right? For example, 5 times 4 and 4 times 5 is the same thing. All right. So multiplication of integers obey the commutative law. So if we work out QP and we get back the same answer, it would mean that multiplication of matrix obey the commutative law also. So let's give it a try. So all right, I'm going to use a fresh page. All right, let me just improvise. All right, so QP. So we're gonna set out, we're gonna write Q first, the matrix Q first. So that's Q. And that's P. All right, how do we multiply matrix? Row by column. All right, so we're gonna get that number first. So it's this row with that column. So it's going to be -1 times 3 plus 3 times -1. All right, and then to get this number here, or that element, is -1 times -2 plus 3 times 4. All right. So, in maths, practice is very important. All right. I once saw a student, to start multiplying, rather than -1 times 3, this 3, he just use negative, he just start multiplying -1 times this 3. You just go haywire. So practice is important. All right. All right, so to get this element down here, we're going to use the second row with the first column. So 0 times 3 at the top there, plus 1 times negative 1. All right, and can you write the last one for me? 5 seconds. Right. So it's going to be 0 times negative 2 plus 1 times 4. All right, and we're going to work out this expeditiously. That's going to be negative 3. A positive and a negative give you a negative. 3 ones is 3. You owe and you owe 6. All right, and you know, throughout the years of teaching, I realized that sometimes the students will get the setting out correct, but the computation part of it is giving them a problem. All right, and what you can actually do, if it is a paper 2 question, because I hardly see these questions in multiple choice, you can actually use your calculator, your bracket function on your calculator. All right, so you don't have to go through all this mechanics. All right, so negative and negative will give you a positive. 1 times 2, 2. 3 fours, 12. 2 plus 12, 14. 0 times 3, 0. Positive and a negative give you a negative. 1 times 1 is 1. 1 from 0 is negative 1. 0 times negative 2 is 0. 1 times 4 is 4. 0 plus 4 is 4. Alright, so ladies and gentlemen, this is now QP. Now let's check it with our first matrix answer. The first one, let's put them right together. Well, what do you notice? They're not equal. So our conclusion is that matrix multiplication, so since PQ is not equal to QP, then matrix multiplication does not obey the commutative law. All right. All right, so let's move on. Let's look at this question here. So we are asked to multiply 3mn. All right. Now that could mean a lot of things, right? What do we do first? All right. Let me tell you what you should not do. Don't multiply 3 times m and then 3 times n and then multiply that. Don't do that. What you can do is to work out 3m, and then when you get answer for that, you multiply by the matrix n. Or what you can also do is multiply the 3 times the n, then multiply m times the product of that. Or what you can probably do, which I'm going to do, is multiply m times n, and then when I'm finished, I multiply everything by 3. I kind of like this one. All right, so let's quickly compute mn. Let me see those of you who can race me to the end. All right. So I'm just setting out this thing here. All right. You can actually pause the video and test yourself to see if you can actually work out m times n. So let's do the setting out. All right. And then the 4 goes with that. And the 5 goes with that. 0 goes with the 3. Negative 2 goes with the negative 1. 0 goes with the 3. Negative 2 goes with the negative 1. Alright, and then that's going to be 12, take away 5, 12, take away 5 again, 0 plus 2, 0 plus 2. All right. Then we end up with 2 here, 2 there. And that's 7, and that's 7. So guys, this represents the product of m times n. And then to get 3mn now, I'm going to multiply everything by 3. So I'll put the 3 there. So what that means, so this is a scale, this is we're doing scalar multiplication here. So 3 times 7. I mean, you don't really have to do, this. Like put the 3 there, you could just do it mentally. So that's 21, 21, 6, 6. And that's your answer. All right. Let us look at part 2. Now, part 2 is a bit interesting. Now, part 2 says m squared. All right. Now, m squared is actually m times m. All right. So, and we know that m is that matrix there. So it's 4, 0, 5, negative 2. We're going to multiply it again. All right. Some students might think that m squared means that you square every element in the matrix. All right. So that would be wrong. So we're going to find m times n, then subtract it from, well, subtract 2 times matrix n. So let me just quickly do that. So that's 4 times 4 plus 5 times 0, 4 times 5 plus 5 times negative 2. And then 0 times 4 plus negative 2 times 0. 0 times 5 plus negative 2 times negative 2. Alright, so that's going to be 16 plus 0. That's 20. Subtract 10. That's 0 plus 0. 0 plus 4. So we end up with 16, 0, 10, and 4. So ladies and gentlemen, this is m squared. All right. So what we're going to do now is to find 2n. All right. Now 2n just means 2 times everything in n. All right. So I'm just gonna try see if I can squeeze it down here, trying to save the environment. So we have 16, 0, 10, and 4. Take away 2 times n, and this is n, so it's 2 times everything inside, so it's 2 3s 6, 2 3 6. 2 times -1 is -2, 2 times -1 is -2. All right, now how do we subtract matrix? Entry by corresponding entry. All right, so when we multiply in matrix, we multiply row by column, but when we're adding and subtracting, it's entry by corresponding entry. All right, so let's set it out. You know, and then the problem I'm having sometimes when students don't want to set out the question and they do it mentally. All right, and then you make a little mistake and then, you know, you lose some marks. Safest thing to do is just to set it out. All right, so right here we're gonna have 16. So I'm gonna show you how to get this number here. So it's gonna be 16, take away 6, 10, subtract 6, 0, subtract 2, 4, subtract 2. So we end up with 10, 4. These two negative here will give you a positive. So that's just 0 plus 2, which is 2. And this is just 4 plus 2, which is 6. And that is your answer. All right, so let me quickly go into matrix multiplication compatibility. All right, so basically we can just multiply two matrix. We can just multiply any matrix. All right, so let us say we have a 2 by 2 and a 2 by 1 matrix. All right, how do we know that these two matrices are compatible? It's very simple. All you need to do is to look at these two numbers. All right, so remember, the first number tells you the number of rows, the second number tells you the number of columns. All right, so this is a 2 by 2 matrix. This matrix has 2 rows and 1 column. Now, if the number of column of the first matrix is equal to the number of row of the second matrix, then they are compatible. They can get married. All right, okay, so number 1 is compatible. Now, the remaining number, the 2 and the 1, tells you what type of matrix we're gonna get, or what will be the outcome. So the outcome would gonna be a 2 by 1 matrix. Now, a 2 by 1 matrix would be just like this: 2 rows and 1 column. All right, let's look at the second one. We have a square matrix, 2 by 2, and a row matrix, 1 row and 2 column. Let's check these two numbers here. What you notice? They're not compatible. All right, so that one is out. Can't get married. Instant divorce. All right, let's look at the third one. Oh, by the way, well, no, once it's not compatible, you can't really look at that, the two end numbers. So let's look at this one now. We have a row matrix and a 2 by 1 matrix. So, sorry, it's a row matrix and a column matrix. So we call it a row matrix because it has 1 row. We call it a column matrix because of 1 column. Let's check out their compatibility. Well, what do you know? Right, they can get married. So these two numbers are equal. All right, so what you notice the outcome is going to be a 1 by 1 matrix. It has 1 row and 1 column. All right. We're on to the fourth one. All right, so as you can see, let's check out this. No, those two numbers are not equal, so they're not compatible. Last one, compatible. Right, so we can work with that one. So what's the outcome? 1 row and 2 column. So it'll be something like this: 1 row and 2 column. All right, so that's it, ladies and gentlemen. So we've just looked at matrix multiplication and matrix multiplication compatibility. All right, thank you for watching and good evening.